All right, we are wrapping up chapter 4 today with the equidistance theorem, and this one does unfortunately involve proofs. However, these are the last proofs we are going to do all year, so you can do a happy dance for that. So the equidistance theorem, and we're going to be talking about auxiliary lines today. So let's jump into it. Our first postulate and definition we're going to talk about is one, that a line is the shortest distance between 2 points. And the definition is that the perpendicular bisector of a segment bisects and is perpendicular to the segment. I mean, it literally means what it says. So we are going to talk about two theorems that we can use to either prove that we have a perpendicular bisector or use to prove other statements, be reasons for other statements, support other conclusions, etc. So the first one, theorem 24, is if 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of the segment. So what this means is if I have segment AB and the point P is equidistant from A and B, meaning AP is congruent to BP. Remember the distance between 2 points, that would be the length of that segment. So if those two segments are congruent, and then if I also have Q, and Q is equidistant from A and B, meaning these two segments are congruent, then the segment or line joining P and Q is the perpendicular bisector. So if I have 2 points and I'm connecting the dots to make what would look like a kite in this case, if those 2 points are both equidistant respectively from the endpoints, then that means that they make up the perpendicular bisector. So let's look at that together on a proof. So starting on example 1 here, we're told angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So I want to show that AC is the perpendicular bisector of BD. And in order for that to be the case, A needs to be equidistant from B and D, meaning AB needs to be congruent to AD, and C needs to be equidistant to B and D, meaning CB is congruent to CD. So how can I show that with the information I was given? Well, if angle 1 is congruent to angle 2, then that means the base angles of triangle ABD are congruent, so the sides opposite them would be congruent. So AB is congruent to AD. And then similarly with this bottom triangle, if the base angles are congruent, then the sides opposite them are congruent. So that's going to be the basis of my proof. I'm going to show that A and C are equidistant from the endpoints, and therefore they make the perpendicular bisector. So let's start, of course, with our givens. Angle 1 is congruent to angle 2. That was given. And that let me conclude that AB is congruent to AD, because if the base angles of a triangle are congruent, then the sides opposite them are congruent. So AB is congruent to AD. Then I had my other set of givens that angle 3 is congruent to angle 4. That was given. And then because angle 3 is congruent to angle 4, I knew BC was congruent to DC. And this is going to be the same as number 2. Save yourself some writing. Okay, so what I have shown here is that A is equidistant from BD, the endpoints, and C is also equidistant from BD, the endpoints. So I have shown that AC is the perpendicular bisector of BD, and my reason is going to be theorem 24, and that is if 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of the segment. This entire if-then statement, theorem 24, is going to be my reason. So I'm going to take time to write that out for reason number 5. If 2 points are each equidistant. Apologize for that interruption. Miss Lavelle was delivering some treats to me. So back to the reason for number 5. If 2 points are each equidistant from the endpoints of a segment, then they determine the perpendicular bisector of that segment. And that is all theorem, exactly word for word, theorem 24. Okay, we are going to do one more theorem and one more proof to go with it. And theorem 25 is that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So what this means is if I already know I have a perpendicular bisector and there's a point on that bisector, I can draw even, it might not already be part of the diagram, but I could draw in a line or a segment connecting those 2 points, and it would be equidistant from those endpoints. So that would be an example of an auxiliary line. That means it is when you draw into the diagram yourself. So in this case, if PQ is the perpendicular bisector of AB, that means it splits it in half and it's perpendicular. Then if R is on that segment, then I can draw an auxiliary line from R to A and R to B, and those 2 segments are going to be congruent because R is equidistant from the endpoints. And similarly, this segment S is also on PQ, so I could draw an auxiliary line from S to A and S to B, and those 2 segments would also be congruent because S is equidistant from the endpoints because it's on the perpendicular bisector. So let's see how this helps us in a proof. We're given that F is the midpoint of BC. Okay, so F is the midpoint of BC. That means it's splitting it in half. And DB is congruent to EC. So tiny little tick marks here. Sorry about that. And then FD is perpendicular to DB, and FE is perpendicular to EC. So these are right angles on both sides, here and here. So we want to prove that AF is also perpendicular to BC. So we know it's the bisector, but we want to show that it is the perpendicular bisector. So let's take a look. Let's start with our givens. And I'm just going to put them all in the same statement. Okay, so that was all given to me, and I'm going to start with my, conclusions. I concluded that BF is congruent to CF, and that's because F is the midpoint. So if a point is the midpoint, then it divides the segment into 2 congruent segments. Okay, what else did I conclude? I concluded that I had a right angle, so FDB and ECF are both right angles. And that would be because of my perpendicular segments. If segments are perpendicular, then they form right angles. So what I have here is that DBF and ECF, I know they're tiny, but those are actually right triangles, and their hypotenuse, BF and CF, are congruent, and their legs, DB and EC, are congruent. So I actually do have congruent triangles because of CTC, I apologize, hypotenuse leg. So triangle BDF is congruent to triangle CEF because of hypotenuse leg. Okay, so let's think about a game plan for a minute. I know that I have congruent triangles by hypotenuse leg, and I'm wanting to show that AF is the perpendicular bisector. So I already know it's the bisector, but I want to show that it's perpendicular. And remember, the way that we do that is by saying that the 2 points are equidistant from the endpoints. Well, I know F is already equidistant from the endpoints because FB is congruent to FC. So there's one point. The other point that would need to be equidistant is A. I need AB to be congruent to AC. Now, how can I do that? Well, if B is congruent to C, those two angles, then the sides opposite them would be congruent. And I know angle B is congruent to angle C because of CPCTC. So that's where I'm going to go next. I know that angle B is congruent to angle C because of CPCTC, which means that AB is congruent to AC because in a triangle, if the base angles are congruent, then the sides opposite them are congruent. Sorry about that, Belle. Okay, so F is equidistant from B and C, and A is equidistant from B and C because these segments are congruent. So that tells me that A and F form the perpendicular bisector of BC, which means that AF is perpendicular to BC. And my reason is going to be if 2 points are each equidistant from the endpoints of a segment, then they determine the perpendicular bisector. All right, and that is it for our notes today, finishing up chapter 4. And again, this is our last topic of proofs for the whole year. So job well done, give yourself a pat on the back, and exhale because it is going to get a little bit easier from here.